vertically stretched, or we say vertically compressed. And then the third thing that could happen is that there's reflection over the x-axis. All right. So as we look at this, then number 1, letter A. All right. So I'm giving you the original. The original is 3x. We want to transform it. When we transform it, we state this right here. This new function f of x, sorry, that old function f of x becomes what we call a of x because it's a new one. We give a name. And then right here, we're telling you what to do with that f of x. So as we've seen, there's 3 things that can happen. And that's what I have listed out. I want you to select which ones are happening and tell me then, is it going up or down? Is it being stretched or compressed? And is it being reflected, yes or no? So, as we saw the last couple days, with a number at the end, a plus 2.5, what does that mean of our 3 options? Yeah, it's being moved up. When we say moved up, it's because it's a plus sign, right? Plus, I think, going up. So we say that goes up, and how many units? That's what I'm looking for, okay? Now, Terry? Now, stretched or compressed. Where does that number need to be located in order to be considered to be a stretched or compressed? Correct. I need to have a number out front there. Now, do I have a number out front there? No. Technically, what number is hiding there? Yeah, and does a 1 doesn't do anything for us, right? So is it being vertically stretched or compressed here then? No. So, whoops, wrong button. So we are not going to answer this one out. We can't. It's not being stretched or compressed. It's staying that same slope. And then the last thing that could be there is a reflection over the x-axis. And is that happening? Yes or no? As we saw yesterday in our notes, what had to be there in order to have going from increasing to be decreasing? A negative. And where did that negative have to be located? Correct. It had to have a negative out front. And do we have a negative out front? No. So is that being reflected? We circled no. So this graph starts off as positive 3x, and it's going to stay increasing because we're not doing a reflection then. All right? The only thing we're doing with this graph is doing what? Going up, staying the same, 2.5 units. That's what we've been looking at the last couple of days. Can you read the notation and know what it means to do? All right, let's take a look at the next one, letter B. I'm starting off with a 4x. All right, let's look and see how we want to transform it. We want to transform that original one by negative 1/2. All right, pieces that we have. Are we having a translation going up or down? No, because this time we don't have anything at the end, do we? At the end goes up or down. So since we don't have anything at the end of that, we are not answering this one out. There's no movement up or down happening. Everything's happening out front this time, correct? What's the first thing you notice out front? A negative. As soon as I see that negative out front, what needs to start coming to mind is a reflection. It's going from increasing to decreasing. Or if it was starting off decreasing, it then becomes increasing. But we do have ourselves a reflection happening, okay? And then we have a number out front, right? Excuse me. And that number out front means it's either going to take my original graph and we say stretch it out, it's going to make it more steep, or it's going to start to flatten it out and we say that compresses it. It's going to make it a little bit more flatter, less steep. So don't overthink that. What does it have to do? Makes things bigger or larger, or larger or smaller? Yeah, so what would you say then? A vertical compression, I think of CPR, pressing down that chest, compressing that chest. So we are saying that there is a vertical compression happening here. By how much? By a factor of? Correct. I know it sounds silly to say, oh, I put that 1/2 there. When there's multiple things happening in there, I want you to know what number means what. Okay? That's it. How about letter C? Give you a second, I could try letter C on your own based off what we just did on A and B. What what could you select off there of what's being happening on that transformation with 2 f of x minus 5? You start off with the 3x, and how's that thing being transformed? Should be a quick circle, yes or no, up or down, compress or stretch. Tell me the numbers that are influencing things. That's what we're looking for. Can you read the notation style? Again, it's not crazy difficult, but if you haven't been paying attention, I could see this being very foreign to you. All right. Excuse me. All right, are we going any movement up and down?
Down.
Because of the minus 5 this time, right? So we are selecting down, and we're going down how many? 5. Sounds good. Do we have a stretch or compression happening here? Yeah, because of that 2 out front. Out front is what we call stretch or compression. So our graph starts off like this, and what's it going to happen? Get more steep or less steep? You're doubling something. What does doubling something do?
Stretch.
Makes it larger, stretches it out, we say. And we say by a factor of that 2. And do we have a reflection happening? Looks like this, it's increasing. Are we going to change it? No, because what are we missing out front? So what are we saying? Reflective of the x-axis? No. Okay. It's going to stay the same. That's it. Take a second. If you have an answer out that last one, letter D, answer it out. Okay. Read through that one. Now this time we're starting off with a negative 3x. We're starting off decreasing because it's negative. Then transform it. How are we transforming it? Negative 5 times f of x. Can you go through and answer those out? Yes, no. If you can, you're good to go. And the where things are located influences that up and down, that stretch or compression. So you got to look at that big picture, that structure. All right. Are we doing any up or down movement? No, because I don't have anything here at the end. There's no plus or minus happening. So we are moving nowhere. Okay? There is no up or down movement happening. What else is happening though? What's the very first thing you encountered? A negative. So we start off as decreasing because it's negative 3x. And then when I throw that negative out there, it now changes it to increasing. Yeah. And what that means is we say in math, there was a reflection happening over the x-axis. Was there a stretch or compression happening? Definitely, because there's a 5 out front. When that number is out front, it's either stretch or compression. So we're now increasing. And what are we going to do now? Increase more or increase less? It's more, right? Because it's 5. What do we mean by times it by 5? Makes it, again, larger, bigger. So we're stretching that thing out. Again, I think of make like a rubber band. Take that rubber band and keep stretching out. It's twice the size, 3 times the size. Eventually it snaps. But you keep stretching out to maybe 5 times its size. We're stretching that out. So what do we just say? Stretch by a factor of? Correct. Okay? That's it. All right. Let's flip it. Let's look at the back side real quick. Now I want you to do the reverse. We're going to do the reverse. I'm going to give it to you in words. And you might want to flip back and forth between the 2 sides. I'm going to give it to you in that description. And I want you to write it 2 ways, like we've been doing. And this is where, again, I think things can get a little confusing. I get it. The first one's going to be in terms of f of x. And the next one will be what we say is the transform function. So what do I mean by in terms of f of x? I want to literally see in your answer something like this. That has f of x in the answer. Okay. What do I mean by the transform function? The transform function means, as we saw yesterday, I'm taking what that f of x is, replacing it right here, and then I'm doing, hey, what's 2 times 3x? 6x minus 5. I'm getting rid of that f of x and just writing x. That's what I mean by the transform function. So let's go ahead and do that. Let's do the first one together. Let's write it in terms of f of x. So I know I have to have an f of x in here. Okay. Now how am I going to transform that? It says I want to vertically translate it up 2 units. So if I'm going up 2, where does that 2 have to be located? At the end, and what is that 2 going to be? That's all I'm looking for, exactly. Now they also said I want to reflect it over the x-axis. So what does that mean I have to have? And where does that negative have to be? That's it. That's what we want to do. Take that description, write the equation. Now that's what we say in terms of f of x. Next thing we want to do is transform it. Put it into that ax plus b I keep talking to you about over the last couple months. So we want to get rid of that f of x. What was it originally called? Just x, right? So we're going to replace that, substitute it. So we're going to replace that. And I would try to clean up anything, but is there anything to clean up? No, like on the last one I just quickly did, we had to do 2 times 3x to get 6x. But because it's just x, there's nothing else to do. So we just say negative x plus 2. You do that for us. For the most part, then you've got a nice crash course over the last couple of days. Okay. All right, taking that element on the next one. Let's look at letter B. Read the description. Let's create the f of x, and then let's create the transform function. When I say in terms of f of x, I should see in your answer there f of x. And when I see the transform function, I should just see an x somehow. So read through that 2 pieces that we want on there. And what do we need to have? And where do those need to go? Where the location is definitely impacts them. So when we say vertically translated down 3 units, what do we got? And where's that -3 going, out front? No. Yeah, if we want to go up and down movement, we have to put it at the end. We got a compression. What's a compression mean? Is it going to get more steep or less steep? Yeah, it's going to get a little bit flatter. And where's that 1/3 have to go? Yeah, in the front. Sounds good. That's it. And then lastly, rewrite it in terms of x. So we look at what the original was. This one's a basic one. It's just x. So when I substitute that in, I replace that. There's really no multiplication tab to do. 1/3 x minus 3. If that was a 10x, we'd have to multiply 1/3 times 10, but we're not doing that. Okay. All right, give you a moment. I'd like you to try the next one there, letter C. Based off what we just did, try that kind of on your own there. We'll talk about it. And like I said, that's a quick crash course. Say that 5 times fast, of what we've been doing.
I got through 1.5.
Okay, Miss Kino.
Before I stumbled.
Miss Kino's up here going quick. I can't do that half the time, so she beat me there. All right. So we have 3 things that are influencing this function. Now I only give you 2 of the 3 things, so where are these 2 things going? What's going out front? A negative. And why am I putting a negative out front? It's reflection doing that. And I heard also out front is going to 2 because we're stretching it. So what is that going to do for my graph? Make it more steep or less steep? Yeah, we're stretching it out. We're doubling it, tripling it, whatever. And there's no adding or subtracting right at the end because there's no up or down movement happening. Last thing is, because it's just basic x, we just pop it out and call it a day. Okay. What are we doing here? What would my graph continue to do? Is this graph increasing or decreasing?
Decreasing.
Because the slope is negative. Sounds good. Last but not least, what do we got going off that last one here? And as you can kind of hopefully see, as I'm telling you what's in my head here, as I'm walking it through, I'm jotting down that stuff I know has got to be there. And now I'm going to come back around and fill in where those pieces go. So where does those pieces go? Where's that 3 going? And what's going to be that 3? Yep, because it says down 3, right? And then lastly, I got a 1/3 in there I got to put someplace. Oh, sorry. I'm not good with numbers. Where's that half going? I'm not good with words either. So it's going to go out front. And when I say compression, one more time, steeper or flatter. Yeah, you're having it. And then because it's just a basic x, it stays as that. Call it a day. Again, quick crash course of what we did. Eventually I'll get that one these days. All right, let's finish up our notes. All right, so go ahead and get out your books. Let's finish up where we've been at, which I have no idea what page that is. So give me a moment as well.
Where are you start off for today? Are you gonna start
I don't know.
Because we got through this yesterday. So we're either going through, are you doing say 3 or 4?
Definitely not doing that.
Then we're going to talk to talk.
Let's talk.
But yeah. We did it today. It was good. I don't have it
Oh,
wasn't
it's
in
not
the
on there.
notes.
Okay.
It was in our notes, so I could print it out.
That's still the assignment.
It's
I'm still here and flip over.
so they're matching.
Oh yeah.
Different.
Yep, that's one we definitely want to talk about. Which
I
is
thought it
nice off of what we just did.
Yeah, I thought it went really well with them this morning.
So let's just piggyback off what we just did with the warm up there. Sorry, what page? It is 54. M2-54, everybody. So we're wrapping up our transformation work today. All right, and then tomorrow the math will be one of our last math is 4, I think it is, maybe tomorrow, which will be focused on transformation work. So let's go ahead and then wrap this up. All right, so on the quiz sometime next week, I'll have a question like this right here with you. You've got how many graphs there? 5 graphs, looks like. 5 lines. We're playing the matching game, okay? I already graphed the original, the basic one, the f of x equals x. We've been seeing that guy the last couple days. In your book, it's the guy that is in what, solid black right there. That's my original guy. Now we're going to transform it. Those are the 4 green lines. And what I want you to be able to do then is match up the 4 green lines with the correct transformation that happened. Okay? So look how he named those 3 green lines. Each green line gets a special name because each one is a different type of transformation. And then let's just go ahead and we'll pop right here what transformation goes with what. Okay. So somebody, as you're looking through things, looking at k of x. Let's just start right there at k of x. We're on M2-54. K of x. Can anybody match up k of x with one of those options there on the right hand side? What? So Chloe's suggesting f of x plus 8. What's the key giveaway for you maybe on that, Chloe? Yeah, it's going right through at 8 here, right? So we started off here at that black center line, and k of x went up pretty darn high. And the only way that can go up pretty darn high is if there's a plus happening off that. And based off her options there, she is correct. That is f of x plus 8. And like anything with matching, once we got one down, let's scratch it off and hopefully we did it right the first time, which we are good to go. All right, what's the next one they would like us to find? H of x. Now when you look at h of x, it's the green one. First thing I notice is it didn't move up or down, did it? It stayed right there at the origin. It just turned a little bit on us. What happened to that slope? It increased. It got a little bit steeper. So what do I have to have in order to increase that slope? Where does that number have to be at? In the front. So I have 2 options here out front. And now those 2 options then, you said it increase. Which one does that for me?
2.
Yeah, you double it. It's going to make it, we say it's stretching it out now. Okay? So what is that going to be? 2 f of x. Sounds good. And we just eliminated another one there. All right, let's go. Let's kind of walk it down. G of x looks like the exact same thing kind of started, right? It stays in the middle, stayed in the origin, just kind of turned on itself. And it turned and made what? Made itself a little bit flatter, right? So what again do we have to have? A number where? In the front determines that steepness. So the only option that we have up front is the 1/3, and that makes sense. If you take a third of something, what does it do? It makes it smaller, right? And we say it compresses itself. So what is that? 1/3 f of x. Okay. Now, if we did everything right, the last one that remains is the -7. And when you look at j of x, does j of x go with a -7? Sure does. It looks like it started off here and went straight down. Those lines are what we said, what's that magic geometry word we said? They are still parallel because the steepness did not change. And what do we have? F of x -7. Sounds good right there. Okay. Now, let's come back around here. We got everything matched up. Nice, cool, we're great off that. Let's add in another one. We'll graph it out ourselves. Okay, so now what I'd like you to do is, KAG, let's call that A of x. And I want you to go on that graph, and let's make this one. I want us to create A of x such that it is negative f of x. So what would that do for our graph? Reflected. So we are currently increasing, right? That's that black one in the middle. We're starting there. And because I want you to create another one that is now negative f of x, it's going to take my graph and reflect it over the x-axis. So when I do that, all right, we're changing the signs there on the negatives, or on the y's, I should say. So we're here at -1, we're now at +1. We're at -2, we're now at +2. We're at -3, we're at, everything on the y's becomes its opposite. We're at 1, we're at -1. We're at 2, we're at -2. We're at 3, we're at -3. Take your ID and make the line. So that's what we call as a reflection. Okay? You can do that for all of us. You're good to go. Okay? Give me a moment there. And then, does our last page have, is there any other things off talk?
No, that's it. And
Just
then it just goes into the assignment.
Okay. Let's see if there's anything worthwhile on the assignment. Yep, there is. All right, let's do some of the practice here. We'll get a little bit more practice and we'll call it a day. All right, and I think actually I used that assignment yesterday, so I'm not going to do that with you. My guess, you know if that's on tonight's assignment, this one here?
Like I said right now.
Before I do anything with you guys, don't have to redo our assignment's about to hit it again.
Which
1, 2, 4, 6, 8, 9.
that's the one, sorry, I don't have it. Here's 2, 4. And then this.
All right, so let's go ahead and flip it to that page, a couple pages down the road. And let's take this one right here. We'll finish off today with this one, all right? So we got our tables like we did. Yes, Victor, let's do this first, okay, bud? We got our table here. They gave us this time 10x, all right? That's our original one that's been graphed for us. We want to transform it based off what we've been doing. What the heck is going to happen to that line? F of x minus 30 means what? Yep, we're going to move this thing down 30 units. And as we do that, our graph, is the slope going to change at all? Just going to literally walk ourselves down 30 units. Now, when I walk this down 30 units, look at our scale. Make sure you're paying attention to our scale. What is our y scale going by? Yeah, it's going by tens, right? 10, 20, 30, 40, and so on. So we're going down 30. So let's move that just carefully down 30 units. We're right here at the origin, go down 30. 10, 20, and 30. We're right here at 10, going down 10, 20, and 30. We're up here at 20, going down 10, 20, and 30. And repeat that, 10, 20, and 30. 10, 20, and 30. Take your ID. Do we need to do every point? Nope. Just enough to get ourselves a nice line. And let's bring back in that magic geometry word. Those two lines are what we call parallel. What are we going to name this line? Bill? George? No, we're gonna call it b of x, right? So f of x, and we're gonna call it b of x. What's that, Victor? I said you want to call it Victor? Okay. We'll catch it next one. All right. Now let's complete the table that we've been looking at. Remember these two columns here. This is my original f of x. This is my now transformed one, b of x. So f of x, when x is 1, where was my y value at? So when x is 1, y value is right here at 10. Okay. When x is 2, my y value is at 20. When x is 4, my y value is at, and where is that coming from? What is my original function? 10x. 10 times 1, 10 times 2, 10 times 3, 10 times 6, times 8, times 9, times 10, times 5,000. Just add on a 0, 50,000. I got you, Colin. All right, now let's go ahead and fill out the table for the b of x. What did we do at the very beginning? All we did was subtract 30, right? We told to go down 30 units. So take that thing down 30 units. When x is 1, we are right here at negative 20, which makes sense. 10 minus that is, 10 minus 30 is negative 20. Keep going there. 2 comma, 2 comma, negative 10, which makes sense. 20 minus 30 is negative 10. 40 becomes what? 10 minus 30, minus 30, minus 30, minus 30, and so on. Okay? And let's finish this off with B and C. We just did that on our warm-up. As you can see here, we want to write the equation of the function b of x, and I see that word general form again. Every time I've seen the word general form, I keep writing that ax x flee to kind of burn that into you guys' heads. All right? So, what do we have here? The original f of x was 10x. So I don't have much room. I know you don't either. I'm just going to write letter b on this side here. So b of x was the original minus 30. We want to put that in ax plus b, so we replace that 10, we replace that f of x with what it was the original. And are there any like terms or anything to do? No. So that answer is letter B. That is general form that we keep harping you guys on about. Okay. And we already described it. We said we were going down 30, called it a day. Okay. That's transformations. It's not too bad, assuming you're paying attention to the work. All right. So let's get in our assignment here for you. It's a little bit earlier than we finished up yesterday on, so that's good. Give everybody a moment here. Assignment's coming out. We'll do like we usually do. Victor, make it quick. All right. We'll do a few examples, or sorry, a few of the problems just to get you set up on, and then we'll let you be. All right. So let's take a look at that front side real quick. 1 and 2 look pretty darn familiar, especially with number 1. 2, we just pretty much talked about one similar to that. All right. So on 1 and 2 there, I'm gonna let you I'm gonna do 2 with you. Let you come back to number 1. As we look at question 2 here, I give you x. Cool. We want to transform it, being described right down here. Based off what we've been doing the last couple days, what's the description here? What are we doing on this transformation? I see 2f of x. So what 2 is going to do for us? What's that 2 going to do? right? It's going to increase the slope. It's going to increase our steepness, right? So when we say describe the transformation, we say it's going to be a vertically stretched or compressed. Stretched by a factor of 2. So that's going to become more steep because we're going to double things, triple things. Come on, Terry. I kicked your desk. Next time I kick you. All right. Now let's fill out that table, knowing we're going to eventually double it. Okay. So the original is f of x. When x is -2, where's the graph? -2. When x is 0, 0. When x is 2, when x is 4, when x is 5,000. Very good, Chloe. Got it this time. Now, g of x, we're doubling it. So we're taking those y values and multiplying it by 2. So when we start off with, we got a -2, and -2 times, 2, we're going to double it. That gets me -4. So we start off at -2, we're going to double it. And as we start doubling this graph should become more steep. Okay, it should begin stretched out. When we got 0, we got still, now 0 still 0. When we got 2, we doubled it. 2 times 2 is 4. And then when we got 4, we doubled it. 4 times 2 is 8. And we keep stretching it out. Take your ID. All those points should be landing on that new line. Okay? It's a stretched out line. It's a steeper line as we expected. Finish it off. Letter C. Write it in general form, ax plus b. So as we keep doing the last couple days, we take what f of x was. This one's pretty basic. It's just x. And we replace that. Whoops, don't want to do that. We're doing g of x. All right. We replace that as what? X. Nope, there's a 2 out front, isn't there? I can't do anything here. My bad. Try this all over again. Try that again. 2 f of x. X was just, f of x was just 2. Finally, third time's a charm. That's it. Do that for us, you're good. The rest of those at the bottom are pretty much what we just kind of talked about. Okay. On number 3, let's take a look at letter B. We're starting off negative, and what's out front on letter B? We have a -4. Just as we saw a second ago, that changes my steepness. That's going to do the same thing on letter B. What's that negative going to do for us? It's going to reflect it. So I'm going to go from a negative starting off with to then an increasing graph. So what I've got going here is I'm going to replace that -2x right here and multiply. What is -4 times -2? Positive, yep, positive 8x. Okay, that's all I need from you. Same thing we've been doing. Letter B. Do I have anything happening now? Maybe think here. Does yours letter next one match the same thing? No, I added that in yesterday. So let's just add this in real quick. On letter 4, number 4, letter A. Thank you. Number 4, letter A. Are we having any transformations happening? Sorry, translations happening? Plus 2.5, right? And what does that mean? We're going up 2.5. Whoops, like right 5. Is there anything else happening with that? No. Now, your letter B has been updated, or on the screen has been updated. Yours says what? -3x and then x minus 3. I updated just a bit right here to get some extra practice in there. So let's just write off to the side then. Let's change that to 4x and change that to 1/2x. By putting that 1/2 out there now, I changed the problem around. We don't have up and down movement happening, do we? So that's why I changed the problem. What do we have then? Compression or stretching happening. Because it's a 1/2. With it being a 1/2, we are flattening it, compressing it by that factor of 1/2. Okay? Let's pause. Let's flip it. All right. And let's see what the back has in store for us. You finish with the ones that we didn't talk about in the front. And let's flip it to the back then. That should still be, I think, the same. I just added a couple things on there. All right, back side we go. Back side is all old school this time. All right. Number 5, that's really old school. Distribute that thing and combine like terms. Put it into that AX plus B form. We haven't talked about that together in a week or so because we've done a heck of a lot of that. Excuse me. So we distribute that -3. Watch it right here. That's a silly mistake I've talked about before. -3 times -1. There you go. Yep, it's +3. Combine like terms. And as I combine like terms, because these things don't have the variables, I can bring them together. The -3n becomes just -3x. Whoa. There we go. And 12.5 plus 3 gives me, again, old stuff. We haven't talked about that recently because we've done it so many times, but this is a good one to talk about. Same thing on number 6. A and B, plug into your calculator. Now, C and D, we can't plug into your calculator. C and D, we need to solve our equation. So let's go ahead and do, which one do you want to do? Let's just do letter D there. This is our equation skills we keep pounding you guys on. We're going to set that equal to -22 and solve it out. So I'm going to create a little bit of an equation. -22 equals 4x minus 6. We want to take that equation and then solve it out. Let's use our equation skills, go back to 5th and 6th grade. Watch your calculator, or use your calculator maybe for some arithmetic mistakes. We got 4 and a -6. We want to get rid of that what? Which one first? The inverse of a -6. And right there is where the mistakes happen. -22 plus 6. That gets me a negative what? -16. Again, you know who you are. If that arithmetic skills are a little shaky, use your calculator to check yourself. And then finish it off. We got a 4 up front. 4 times x. And the inverse of multiplication is division. Watch your calculator. -16 divided by 4 is a -4. I'm running out of room there. I'm going to write it off to the side. You do letter C this the exact same way. You will not get the same answer, but you get a nice answer. Okay? All right. And then there it is again. What are we selling this time? Cinnamon pecans. Everybody, cinnamon pecans. Mr. Rich likes those this time of the year. You into those, Miss Keno?
Not pecans.
Not pecans. All right. So with number 7 here, we got a lot going on again. A lot more going on. Let's go ahead and finish it off. All right. So on number 7, we're selling pecans or pecans. However you want to say pecans, pecans. I guess that's more of a southern thing. All right. So we're selling pecans here. So P is representing the number of bags of pecans sold. I'm not much of a pecan person myself. We're making money. What do we call that money? Call that ourselves our earnings. That has not changed up, has it? Now, how are we going to make this money? We're at home time, all right, our home game. So we don't have to worry about, in this case, any concession stand fees or anything like that. And we aren't giving away any freebies. So what do we got going on here for our equation, for our function? I say, as we've done with hot chocolate and pretzels and everything, we take whatever that number is, taking it times P or X or C, whatever we've had there, and then we've either subtracted something, which we're not subtracting anything out. All right, let's go label these axes now. We got an equation. Let's look at the graph because we can, but let's make sure we're looking at the right things. The x-axis is always representing that independent variable we labeled, which in this case is the pecans, right? And then our y-axis has always been the earnings. Sometimes we can use the graph, sometimes we can't. So as we get to letter C here, we can use the graph to figure out where the heck we are at. Okay, we're not giving anything away, are we? So we should already be in the positive. And I didn't change that, did I? 4 cups of, let's go with 4 bags of pecans. So what if we sold 4 bags of pecans? And that is the right graph though. Okay, if we sold 4 bags of pecans, where are we located? 4 comma 10. So we sold 4 bags and made $10. Sounds good. Okay, that is at least the right graph. All right, all well and good as we've been doing here, just kind of taking it the next notch. We can't see 100 bags on our graph. That's the next part there, letter D. So we can't look off the graph nice and easy. We use our equation there. So we use our equation by plugging in 100. So what that means is we what? Sold 100 bags, and go to your calculator, use your equation, $2.50 times 100. In your science class as you go, just move the decimal 2 places to the right. So 2.50 becomes how much money made? $250. And if not, use your calculator. All right, that's a nice little chunk of change. Again, as with anything, just don't necessarily start up a business and hope things all work out. You gotta have goals. In this case, our goal is to make $500. So we're making that 500, not plugging in like I just did. I'm creating an equation. I'm creating 500 is equal to how I'm getting to that 500, that 2.5p. Now we did that up above a second ago, right above there. We solved for an x going backwards. And then from here, 2.5 times the inverse multiplication. Divide both sides by 2.5. This would be a good one to say have your calculators on. Okay, go to that calculator, punch it in. 500 divided by 2.5 gets us how many bags? How many bags sold? 200 bags. 200 bags sold. That gets us to that $500 goal. Cool. And as we keep doing, if you've been paying attention during the practice, we then go ourselves to an away game. We're going to take our pecans on the road here to the away game. And as we can see here, being at the away game, we had to have a charge of $75 to use the concession stand. Oh, and we're giving away a few extra things, aren't we? So we've got to account for both of those minuses. So we have not encountered one of these, I think, yet, where we have to give away 2 things. We're still charging $2.50 a pop. We're still talking about the number, bless you, of bags of pecans. We're still making money, or hopefully making money. But because we're giving away some money here, we got to make it back then. So we're going to have to sell quite a few bags that are pecans. So to make that pecans bag, or pecans earnings, that EFP is equal to, got to make the money first. We're making the money by charging $2.50 a pop, so 250p. Cool. But now we have to subtract out like we've seen before. What I've seen in the past is students remember to subtract out the 75 and then stop. I got to subtract out the 75, but what else are we also doing? Yeah, we're giving away 10 bags. And what does 10 bags translate into for money lost? Correct. Each bag is costing us $2.50. So I'm not giving away $10. I'm actually giving away $25. So that's what we got going. That looks silly though. 75 and 25 are like terms. What's 75 and 25 combined to give you? So really, I'm going to clean up that equation and subtract out 100. So 250p minus 100. What's that like? It's like if you own your own business. You got to pay for the mortgage. You got to pay for your product. You got to pay for the utilities. You got to pay your employees. You got to pay for your employees' health insurance. Those are all those minuses that keep happening on there. Eventually, it's just going to be one big old minus. And then, however you're making money in from selling whatever products you're doing. That's that 250p. Okay. All right. That does it. Whoops. That does it. You're going to finish up that ones that we've skipped over, which is only a handful. And then making sure you're on math yet. We've been up through unit 3. Are you up through unit 3? So if you don't have math yet done through unit 3, you need to keep working on that. Tomorrow we're going to get into unit 4. Okay? So in just a minute, I'm going to call you out